Hi, and welcome to another Hopper on microcontrollers video. Hopper is a modern curly brace and semicolon language similar to Java or C#, but designed for small devices. This is a troubleshooting video, this one, and it's how to unbrick your Hopper. It's not really bricked, but I'll explain. So we've got a little tiny 2040 from Pimeroni here, and it has a little NeoPixel RGB in it. And so this is the Hopper development environment. It's in the shell, which is also Hopper. I build from the menu here. I could say build. And when my compilation is finished, I can run this in the debugger. Launch with the debugger. And bottom of the screen, it says it successfully uploaded it. This is the serial console here. So this is going to write R's, G's, and B's to the serial console and alternately flip the LED. This is not a NeoPixel LED, this is an RGB LED. So let's get it running. And we should start to see our LED changing colors. All right, and that's kind of how you expect your Hopper program to work. So I'll Control C out of there. And now, if I unplug that, and restart it. What Hopper does is it'll go and start running the last program you uploaded, which is a feature. Arduino does the same thing. Problem is, if your last program you wrote is catastrophic, which doesn't often happen, but I've been writing drivers and I can quite easily see doing something with a serial bus like I2C or SPI that actually hangs the device. And it could get there so quickly that when you start the device, it immediately goes straight there and hangs, like if the first thing you do is initialize your screen, for example. So that there's no time for the debugger to call in via the serial port and break. So effectively, your Hopper device is bricked because you can't get a new program on it. You can't replace the broken one with an attempted fixed one. So how do we deal with this? Well, recently in the releases on the GitHub repo, I've added another UF2 file. So we had the original ones, the generic Pico one, which is used by a lot of devices, like this Pimeroni is using the generic Pico UF2. There's the Pico W UF2, which has Wi-Fi and it's significantly bigger. And then there's the one for the Challenger, which has a different set of Wi-Fi. So it's got a different Wi-Fi to the Pico. But all the other boards can use Pico. And if there are new boards with Wi-Fi, I'll have to add that use different Wi-Fi coprocessors to the Challenger and the W. I'd probably have to add another one. But I recently added this UF2 here. It's the generic Pico, but it doesn't load the program. It just sits there so that you can break in with the debugger. So let's see how that works. I've already downloaded all these UF2s, so I've got them in a folder on my desktop here. So let's get rid of this screen. Yeah. There's a lot of boards nowadays. Those are all the boards in the boards folder, library boards. So over here where I include the board, that's where I get it from. Go find your board. And there's a good reason to use them because it defines all the pins and the features available. So if you try and use a feature that's not available on your board, you'll get a compilation error rather than a runtime error. So it's worth going and looking at the boards and using, even though you're using a generic Pico UF2, it's important to include the source for the board. Right. Okay, so here we go. So what I want to do is I want to reflash my supposedly broken Pico with another one that doesn't load. So unplug it, hold down the boot select button, plug it in again, and it launches itself as a USB drive like that. And then I drop the no load onto it. So this is the no load Pico. All right. So now let's switch back and let's unplug it and plug it in again. And it doesn't start. So the RGB doesn't start. That's just like the power light showing that it's on. So now if I go again and I go build this, and now I load it up, the debugger breaks in successfully. That's why it says successfully uploaded. Like if it was running, it would say break in the serial port window here. And F5, I'm running. So I'm running in the debugger again, now light's flashing. Control C, exit out of here, unplug the device, oops, and plug the device in again, and no program running. Okay, and then obviously, once you've solved your problem, now that we can break into it, we can actually go into the boot mode from the command line, because we can break in with the monitor. And there's the extra commands for microcontrollers, and one of them here is to enter boot select mode, this B here. Boot select. It's just popped up this window again, and now I can put the proper one back. Great. And now if I quit out of there, and we'll switch back to the other view. So now that program automatically starts. So because it was still there, it was still uploaded to the flash. The only difference between these two UF2s is this one here will not start the program when you power it up. And you can use it on the other boards too. It just doesn't have Wi-Fi, but you can use it to get out of trouble. Anyhow, I think that's all you need to know about how to not launch the program that's currently on the Pico. And this is an easy way to do it. The other way to do it is to rebuild it in the Arduino IDE and make your own UF2, but who wants to do that? It's too much effort. Anyhow, I'll leave some interesting links in the playlist at the end of this video. Thank you for watching. Let me know if you get stuck in this kind of way.